and today I'm gonna explain another astable question. Okay, so now let's look into this question itself. Okay, so for this question we have a kc value. Okay, so we have a kc value. Okay, so this kc itself, let's take a look. The value is not small enough. Okay, so we probably cannot use small approximation, but then it's okay, we'll see. Okay, so we'll see what else we could do. Okay, so then it's asking you what's the equilibrium concentration of ICl. Okay, and then if you have these two were initially mixed in a 2-liter flask. Okay, so then basically again our given information for this question will be you have initially we have I2. Okay, then I need to use a question mark. You go, why do I have 0.45? But that's moles, right? That's moles. That's not molarity. Okay, so you do need to do a quick calculation first. Okay, so that's why let's do that. Okay, so I'm going to use a different color. So moles over liter. Okay, so make sure you do this, otherwise everything will be just off from this point. Okay, so you have this. Okay, and then what about the other one? We'll do the same, right? So you'll have initial concentration of Cl2, and then we'll do the same calculation. You have 0.45 divided by 2 liter. Okay, so the same concentration. Okay, so then you have 0.225. Okay, so these are the initial concentrations. Okay, so that's what we have. Remember, we also have a given info that Kc equals to 0.11. Okay, and then we're looking for the equilibrium concentration for ICl. Okay, so that's something we're looking for. Okay, so you go, I have initial, have equilibrium. That means I have to set up the ice table. Okay, so let's do that. Okay, so again, I like to put down the equation. Okay. Okay, so that's what you have. Then we're gonna have the S table. Okay, ICE. Okay, and then let's fill out the info we already have. Okay, so you have this 0.225, 0.225. Okay, and then initially, remember, you didn't mention, so this implied that's 0. Okay, so that's what I have. Okay, and then what's the next thing we're supposed to do? Yes, we're supposed to calculate Q, right? Okay, so let's calculate what the Q value should be. Okay, so Q will be, as always, right, products over reactants. Okay, so for the products, okay, so we have these two values, 0.225 times 0.225 divided by 0. Okay, so we know this equals infinite. Okay, so Q will have to bigger than Kc, which means what? Which means direction is gonna go to the reactant side. Okay, so therefore we could decide the change for the products are the negatives. Okay, they will have the negative sign. Okay, so your actual reaction goes to the reverse direction goes to reactant side, so this will be the negative, this will be the positive. Okay, so that's also important for you to decide. The next thing you have to see the coefficients, right? Okay, so the change, the x go by the coefficients, right? So then that's why you have positive 2x, negative x, and x. Okay, so now the next thing you could just, right, have this. Okay, so that's what we have. Okay, after you have this set up, okay, so you could lay out the Kc. Okay, so lay out the Kc. Okay, so Kc will equals to what? Okay, Kc equals to the products. Okay, to the products. Okay, so it's the same expression, right? Products over reactants and squared. Okay, so that's what I have, and then now we're gonna use everything at equilibrium to put into this expression. Okay, so then you can have 0.225 minus x times 0.225 minus x divided by 2x. Don't forget about the square. Okay, so that's what I have, and then equals to 0.11. Okay, so now you go, I should be pretty happy about this situation, right? So you're gonna have the squared 2x squared equals to 0.11. Okay, so if you have square on top and the bottom, you could do square root. Okay, so again, if just say you don't have this perfect situation, then if you have a very hard right, just say you can't do the square root on both on top and on the denominator, and then remember this x, and or if your equilibrium constant is small enough, right? That will be a change, right? That change is involving an addition or subtraction situation that could be small enough that you can use small approximation. Okay, but for this situation, we can't. The reason for that is your equilibrium constant is not small enough, and then, however, it's fine because you do have this square on top and on the denominator, and so which means you can do square root on the whole equation. Okay, so we're gonna do square root, and on the top we'll just 0.225 minus x divided by 2x, then equals to square root of 0.11. Okay, so then we can solve for this. Okay, so then you're going to do cross multiply, then solve for x. Okay, so x will equals to 0.135. Okay, so that's the x value you solved, and then from here you go, what are we looking for really? We are looking for the equilibrium concentration for my reactant, so you're looking for 2x. Okay, so again, you can use 2 times the x value you saw, which is 0.135, give us the final answer for this particular question will be 0.27. Okay, so that's the concentration of ICl at equilibrium, and this is something you just solved for. Okay, so that will be the this question. Okay, so you are using, actually you didn't get to use small approximation because KC was not small enough. Okay, but we did run into an easy calculation again because you could do the square root on the whole equation on both sides, and then that's why the calculation wasn't so bad. Okay, so this will be this example question, and thank you for listening. Hopefully this is helpful.